Aloha kako. Hello everyone. My name is Alyssa Leinani Grace, and I'm an outreach assistant in Hilo, Hawaii at the International Gemini Observatory, a program of NSF's NOIRLab. Today I want to talk to you about a recent discovery of the most massive quasar found in the early universe and the first to receive an indigenous name, Pōniuāʻena. So to start, I'm going to share my screen so that we can see some beautiful pictures of this quasar. If you'd like to learn more about Pōniuāʻena after this video, you can read about it in our press release from June 25th, 2020 on nationalastro.org. Pōniuāʻena, aka J1007 plus 2115, was discovered with the help of two programs of NOIRLab, the International Gemini Observatory and the Cerro Tololo Inter-American Observatory, and additional Maunakea observatories, including the MKO Observatory and the University of Hawaii-owned United Kingdom Infrared Telescope. Pōniuāʻena means unseen spinning source of creation, surrounded with brilliance. As you'll learn, the beauty of this name is that it really does describe some of the most important characteristics of this object. And what better way to learn than to compare and contrast this object with another famous Hawaiian named object, Pōwehi. In April of 2019, Pōwehi was the first black hole ever captured in an image with something called the Event Horizon Telescope. It garnered so much recognition and celebration as an astronomical achievement that Governor Ige declared April 10th as Pōwehi Day in our state of Hawaii. Now, let's dive into the similarities between Pōwehi and Pōniuāʻena. To start, both Pōwehi and Pōniuāʻena were named by Ahuahei Noa, a collaborative effort led by the ʻīmilo Astronomy Center dedicated to naming astronomical discoveries made from atop Maunakea. This photo features the naming of two unusual asteroids in our solar system. Pōniuāʻena was named more recently by a cohort of 30 Hawaiian immersion school teachers. Both Pōwehi and Pōniuāʻena are active galactic nuclei, meaning they live at the center of their host galaxies and produce a lot of light. They both have extremely massive black holes at their centers, billions of times more massive than our sun. And appropriately, their names both start with Po, a word sourced from the Kumulipo, the Hawaiian creation chant. In both of these names, Po means profound dark source of unending creation. On this slide, we have a simulated visual on how black holes produce light. Essentially, as surrounding materials, mostly gas, get pulled in by the gravity of the black hole, the materials swirl around it first and are heated by friction. As the gas finally falls in, they release electromagnetic radiation, aka light. That swirling spinning motion, which then produces that brilliant light, is reflected in the ending of the name, Niuāʻena. And with that, we finally come to our first big difference between these objects. Pōniuāʻena is a quasar, and Pōwehi is a supermassive black hole. So what's a quasar, you might ask? Well, quasars are powered by supermassive black holes. But to really explain what a quasar is, we need a bit of a history lesson. In the 1960s, astronomers found what looked like a star at the location of an unidentified radio source. But when they collected the data from that source, the spectral lines, sort of like stellar fingerprints, were very different from stars. So they named these sources quasi-stellar radio sources, or in short, quasars. It turned out that these were not stars at all, but actually really bright and very distant active galactic nuclei. As we can see on this graph of our universe's history, Pōniuāʻena, as we observe it, lives at a point 700 million years after the birth of our universe. We are located at the end of this graph. That means Pōniuāʻena's light traveled 13 billion years to reach us. Pōwehi, on the other hand, is observed and exists during a period closer to our own, at a distance of only 53 million light years. This comparison of distances makes it all the more impressive that Pōniuāʻena's light is bright enough to reach us at all. Most quasars live in the early universe, but Pōniuāʻena, as the second most distant quasar discovered yet, is truly a great shining beacon of information from our cosmic past. This distance is also why our pictures are so different. Pōniuāʻena is so far away that some of its details are harder to resolve, and so we have an artist's impression to represent what it could look like. This graph also speaks to how impressive Pōniuāʻena's mass is. Pōwehi had all this time, 13 billion years, to gather mass, but Pōniuāʻena didn't, and it's still nearly as massive as Pōwehi, which brings us to our big question of how could something so massive form so early in the universe? The mass of Pōniuāʻena really pushes the limits on our current understanding of how our universe grew into what it is today, a fairly stable place in which planets and life like ours can exist. Mahalo nui for watching this video and learning about these objects with me. For more awesome discoveries and pictures, follow NOIRLab Astro on Facebook, Twitter, YouTube, or Instagram. And for more fun What's in the Sky Tonight images like this one, you can follow the Maunakea Astronomy Outreach Committee on Facebook. Ahui ho and take care.